Okie dokie, sorry about that. I thought I had placed this in the pile of stuff that I would bring with me, and it was not. So here's my data set. I will upload this into the Learning Management System, D2L, so that you guys can see it. But basically what we can see in this data set, if you look at it, is that we have two different baseball players, Babe Ruth, Hank Aaron. And we have, they didn't play the same seasons, but we have each of their first season, second season, third season, fourth season, and all that. And what's in the columns is the number of home runs that each of them hit. So, for instance, Babe Ruth's rookie year, he hit 0 home runs. Then 4, then 3, then 2, then 11. And the reason why he was known as such a home run great isn't because of these first few years that he played, right? It's because when you get up here to, say, his 8th season, he had 59 home runs in 1 year, okay? And then keep going, his 14th season, he had 60 home runs, okay? So as you look at that, you go, wow, he had a lot of home runs. Like this year was 54, this year was 49, 46, and all that. And then we can see he starts tapering down a little bit and getting fewer and fewer home runs during his later years. His 22nd season, he only got 6 home runs, but that was better than his first, 4 years. So that's still good. And then he only played 22 years. So this is one of those cases where we don't have a data point for his 23rd season. And we do have 23 seasons for Hank Aaron. So for his 23rd season, there's nothing there. They don't put a 0, because if you put a 0, that would make us think that like his rookie year, he had 0 home runs. That's not true. We actually don't have a data point for that 23rd season, if that makes any sense. Okay, so then same thing for Hank Aaron. And we see that he actually had a better start. He started with 13 home runs his first season, and he did really well. He does not get up to the maximum of 60 that Babe Ruth had. However, he does get up to, 40 is his maximum? I thought he had 49 somewhere. Okay, I guess it's 45 is his maximum. That's all I see. Okay, so 47, there's one. Okay, so he gets up to 47. And then his last season, his 23rd season, he only had 10. So he scored, his home runs ranged from low of 10 up to 47. So he's actually a little more consistent. His home runs are, it doesn't matter which season you pick. Of course, at the beginning and the end, it's lower, but he's still going to hit some home runs. Whereas Babe Ruth had 5 seasons where he was in the single digits, right? Whereas we see Hank Aaron didn't have any. However, Babe Ruth was considered the home run great because he had the most home runs in one season, 60 for a long time, until like Sammy Sosa and Jerry Maguire, those guys. Jerry Maguire? That's not right. Yes. Yeah. So those guys started coming around, in the 90s or early 2000s, I think 90s. And so they started breaking some records then. But we also have to consider, usually I have a huge conversation with my students in class about this. And they'll say, well, what about differences in the layouts in the field? And what about differences in the composite for the bat? And what about this and what about that? And there's always, stuff you can say like, well, that Sammy Sosa, he has a little bit of an advantage because of X, Y, and Z. And you're probably right, but that's probably why, Babe Ruth is going to always be considered one of the home run hitters, one of the greats. So it doesn't matter who else comes along and breaks records, right? These guys were forerunners, let's say. They're both considered really great. Babe Ruth had really high seasons. Hank Aaron didn't quite get as high, but he was very consistent, whereas Babe Ruth was a little all over the place. He ranges from 0 as his low score up to 60, which is a huge range. So actually, in a little while, what we'll do in a couple of videos probably, is we will look at this data, these data right here, the two sets, and we'll try to determine, okay, which of them is better statistically speaking. Just at home run hitting. I'm not talking about anything else, like whether or not they could run to base or whether or not they could, get an earned base, just a single or a double or something like that. I'm not talking about any of that stuff. I'm talking home runs only. Okay, so what we're going to do is we are going to take, Babe Ruth's data, and we're going to make a box and whiskers out of it. Okay, and we're going to follow some basic steps, and I think that you'll be, if you'll just just go with it for a minute and don't stress out about what we're doing, I think you'll find that the steps are not too difficult in creating a box and whiskers, because you're going to have to do this on an exam. So first up, make a number line. Okay, and we're going to use Babe Ruth, so I'm going to label that here. And it's actually fairly easy for him because his minimum was 0 and his maximum was 60. So that's nice because I can split that up evenly pretty nicely. Hank Aaron's a little bit more iffy. So what you can do, I think I have his here. Maybe, we'll see. But what you can do is you can do Hank Aaron on your own. I don't think I'm going to take time to do that here. If I have his, I will show it to you. I think I do. I'll have to find it. Anyway, so this is going to be easier to split up, and well, we may do Hank Aaron. I'm sorry. I'm trying to decide. We're probably going to do Hank Aaron anyway because his data is a little bit different, and it shows some more interesting stuff about how we would handle particular types of statistics. So we're going to deal with. We're probably going to do them both. So I'll probably fast forward through Hank Aaron. But for Babe Ruth, let's just do his nice and slow. This is a number line, and I'm going to go through and I'm going to put points on here, data points for every one of Babe Ruth's scores. Okay? So what I want to do first, before I do anything else, is I'm going to split this up just like I would a number line. So I'm going to say right in here somewhere, about the halfway mark, that's a 30. And then I'm going to split this up, and that's going to be a 10. And a 20, 30, split this up, and that would be 40 and 50. So it's just a nice little number line, and I know it encompasses his lowest score, which was a 0. I'm going to put a point for that, and his highest score, which was a 60. I'm going to put a point for that. Okay, and then we're going to come through, and it doesn't have to be exact, and I'm going to put in some data points for the rest of his stuff. So he had that 0 season, then a 4, a 3, and a 2. Okay, so I'm going to put points on here for 2, 3, and 4. And again, they don't have to be exact. I just need to kind of mark the space. We know 5 would be somewhere around here, so I'm going to put a 2, a 3, and a 4. Okay, next, he had an 11. Okay, so I'm going to put one right in here somewhere. I'm just going to call him out. He had a 29, so that's going to be up here almost to the 30. He had a 54, so that's going to be not quite halfway between 50 and 60. He had a 59, so that's almost to 60. He had a 35, which is down here, middle of 30 and 40. A 41, just barely bigger than a 40. A 46, which is barely bigger than a 45, so it's barely bigger than the halfway. A 25, halfway between 20 and 30. This is just plotting points, right? No big deal. A 47, so be careful because this was a 46 right here. So it needs to be just slightly bigger than that. And if you need to, you could like label 46, 47 so you can see what they are. He had the 60, which we've already got in there. He had a 54. Now hang on. This guy was a 59. This guy was a 54. We've already got a 54. Oh, so I don't have to put that second 54 season in there? No, you do, right? You have to make sure we see both seasons. So the question becomes, well, how do I make you know that there are two 54s? And normally, somebody in the classroom will say, can we stack them? And the answer is absolutely we can stack them. Remember that dot plot that we showed with the representation of data? That's one way we can do it. We can stack the points. So here's a 46. We already had a 46, so we need to stack that one also. 49. I don't have any of those. I'm going to stick one right there, almost a 50. 46. So that's 3 46s. So I'm going to stack 3 46s up there. There's another 41. There was already a 41 there, so I'm going to stack that guy there. And a 34. What was this guy? This guy was 35, so this is a 34, slightly to his side. A 22. I have not seen any 22s yet. And a 6. Okay, so I'll put the data up in just a second so that you can just kind of pause it if you want to see the data. But to check myself, what I'm going to do is I'm going to count the points that I have on my number line, and I should have 22 seasons, right? So 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So I have a data point on my number line here, and here's the data. I'm going to show it in case you want to pause, and then you can see it. But I'm going to upload this into the learning management system so you can have it open that PDF or print it or whatever you want to do. Okay, because you're going to use these data for a couple of different things, including a project we're going to have. So I'm going to load it up. But anyway, here we go. So there I've got all 22. I know I've got all 22 because I counted them, right? So it's easy to make sure you got all your data points accounted for. No worries. Okay, cool. So then what? I've got my data points laid out. And the next thing that I want to do is find something that's called the median. Okay, so this is where we're going to get into a little bit more of the statsy stuff. Everybody should know about mean, median, and mode. If not, we'll make a video on it and go from there. But basically, so number one, put your points in order. Data points in order. I didn't do that, but number two, points on a number line. Those two we've done. Okay, number three, find the median. Okay, so if you don't know what this is, there will be a video talking specifically about mean, median, mode, but I'm going to give it to you. This is the data point that is in the middle. Okay, so a lot of times people will go, whoa, I need to go 1 for 1, 1 for 1, 1 for 1, 1 for 1, and count down until I get to the middle guy. Okay, I've seen people do that. In my case, I'm going to use a little bit of math here, and I'm going to say, well, there were 22 data points, so that middle point would have 11 on one side and 11 on the other. So I'm going to cheat a tiny bit, and I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So somewhere in here is my median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so the data points that's in the middle, well, there's not one there. Or if you have an even number of data points, like we do, it is the halfway point between the two in the middle. The two middle data points. Okay, so what does that mean? Well, sometimes you'll have an odd number of data points, like we will whenever we do Hank Aaron's data, because he had 23 seasons. So what that means is he'll have 11 data points on one side and 11 data points on this other side. That'll be 22. And then we'll be able to find, hopefully, his median will be a data point in the middle, 23. And in that case, it'll be like we're teeter-tottering around that point. It's kind of like on the playground, right? It'll be the fulcrum, and we'll have 11 over there, balancing against each other. Well, here, in this case, because I have an even number of data points, he had 22 seasons, I don't have that guy right in the middle, one data point that I can use. So instead, we find what are the two data points right in the middle. Well, this guy was a 36, right? And this guy was a 41. Let me check. That might have been a 35. I think he was a 36. I should have written him down too. He's a 35. All right. This guy is a 35. And this one is a 41. So we say, okay, I've got 11 on one side, 11 on the other. Find the halfway point between those. So in that case, all I'm doing is taking those 2 points that are closest to the middle, add them up, and divide by 2. We're going to average them, right? Okay. So whenever I do that, I've got what? 76 over 2. And when I divide that, I get a 30. Is that 38? Yep, 38. Okay, so my median here, where I just drew this really tall vertical line, that's a 38. That's my median. Okay, so that was my step 3. Find the median. Okay, did it. No problem. All right, now, if I've done it correctly, and if the data is nice, this data is pretty nice. Sometimes it's not so nice, and we'll see that later. But if it's nice, then I should have 11 on one side, 11 on the other. So the next thing you want to do, number 4, is you want to look above the median and below the median and find, we'll call it a median, for the top half of the data points. And for the bottom half of the data points. Okay, what the heck does that mean? It means don't pay any attention to what's going on up here. We don't care about that stuff right now. Just look at one side. I'm going to look at the bottom half first. Okay, inside of here, I will look as if these were all of my data points. There are 11 of them, and I will find them what would have been the median for the bottom half. Okay, now there are 11 data points there, so I'm going to again use a little math. 11 divided by 2 is 5.5. So I should have 1, 2, 3, 4, 5 data points on the bottom. 1, 2, 3, 4, 5 data points on the top. And look, in this case, there were 11 data points. That's odd. And I have a data point here, that was 11, where I can actually say, oh, there are 5 on the bottom, 5 on the top. That splits that data in the half. The 11 is the teeter-totter, okay? It's the point where I'm balancing 5 on one side, 5 on the other. So there were an odd number of data points here, so I can put that there. So I'm going to draw another vertical line here. Okay. Then I'm going to do that same thing on the top half of the data. So again, ignore the bottom half of the data. We don't care about it right now. We are just looking at these 11. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It looks to me like the 47. If I split it right there, I'll have 5 in here, and I'll have 5 in there. Okay? So when I'm done, I should have 3 vertical lines. One is the median, and then one is the median for the top half of the data points, and one is the median for the bottom half of the data points. And here I am, I'm going to make the box like that. So I just drew horizontal lines between the 3 verticals. Okay, the minimum score is down here, the maximum score is here, and you can see why they call it a box with whiskers. They're talking about like cat whiskers, right? Okay, so box and whiskers, and I've got all of my really important data points represented here, and I'll tell you what they call it in statistics is a 5-number data summary. Okay, so, and I'll talk about that. That's the minimum here. That's the very bottom. Okay, the maximum up here. Okay, the very top. We already knew those. Those were easy, right? The median, which is just figuring out which guy's in the middle. Okay, and then the top half split up and the bottom half split up. And now here's the deal. These are actually called Quadrant 1, Q1, and Quadrant 3, Q3. Okay, so the problem is that whenever I tell you what I'm about to tell you, it kind of freaks people out. There are 25% of the data, approximately. Again, sometimes real-world data isn't exactly lovely. There's 25% down here on this bottom whisker. There's 25% in the bottom half of this box. There's 25% in the top half of this box. And there's about 25% on this top whisker up here. Okay? Now I say about and approximately and close to and stuff like that. And the reason why is because there were 22 data points, right? Well, when I split 22 into fourths to find out what's 25% of 22, I get that that's 5 and a little bit more, right? So that's why whenever I look down here at this bottom whisker, I have 5 data points there, right? And that's close to, we'll put the little approximately, not quite exactly, but close to, oops, you can't quite see that. I'll do it in a darker pen. Close to 25%, okay? There's 5 of them there. Okay, what about in this box? We're not going to count what's on the verticals on these lines here, okay? What about in this box? Well, I've got 1, 2, 3, 4, 5, okay? That's about 25%. There was this one guy on the end. We're not counting him. And when we did the median, remember, it was 22 data points, so the median is not actually a data point in this case. What about the top portion here of the box? Oh, there's 5 points in there. 1, 2, 3, 4, 5. So it's got about the same number. And on this whisker, 1, 2, 3, 4, 5. And again, we're not going to count the guy that's on Q3 there. Okay. If you actually took that percentage and figured it out, or the 25%, it would be 5 1/4, right? So then, 5 and what? 22 divided by 4, 5 1/2. Okay. So we would have to say, oh, half of this data point's down here and half of this data point's here. Half of this data point's down here, half of this data point's up there. We don't really want to get too technical about that kind of stuff, so I'm not going to mess with it. But if you got into a more advanced statistics course, they would start talking to you more about that Q1 and Q3 and what's going on. For our purposes, what we need to know is that Q1 is on the top of the first quarter. This is 25%. So when we talk about quartile 1, quarter 1, the first quarter, it's the number that's at the top of that, according to where we split it. Now, here we actually had 11 data points, so this is a data point, but what if that had been 10 data points? This would not be a data point, right? We would have split between 2, so we would have done this averaging thing that we did on number 3. So sometimes it's a data point, but sometimes, like right here, it's not a data point. So just be aware of that. Okay? And then we've got the median here, which is exactly the halfway mark. By the way, that is the top of quartile 2, right? So you could call the median Q2 if you wanted to, but most people just call it the median because that's its statistics name. And then this guy right here, which was 47, this was 11, this was 38, I got him. 47, that's called the Q3, which is the top of the third quartile. What it means is that 47 is above 1, 2, 3/4 of my data. Okay? If I look at this 38, it's above 1, 2/4 of my data. And if I look at this Q1, which was 11, it's above 1/4 of my data. Well, what does that mean for my maximum? If I look at 60, I've got Q1, Q2, Q3. Well, the entire set of data is represented up here with Q4, right? So quartile 4, 4/4, well, that's 100%, right? So what that's telling me is that below 60, I should see all 4/4 or 100% of my data should be 60 or below, okay? So I'm looking at that, I'm going, oh, okay, I've got it all represented in there. So again, real world data isn't always nice and pretty, and it doesn't always split up beautifully, so it's as close to 25% as I can get. And sometimes you just have to make a judgment call. We'll see some of that. All right. Let's see. Step 5 I actually already did, which is close the box. Close the box. And step 6 I actually already did, with just draw the whiskers. And that is how we make a box and whiskers plot. Okay? So later on, we're going to do a little bit more mathy stuff with this. So again, hang on to these box and whiskers because we're not going anywhere with them. We'll come back and do some more math with them. But real quickly, I want to do Hank Aaron. And again, I'd like for you to try to do this as much on your own as you can, because I'm going to zoom through this. So if you're like, oh my gosh, she's going too fast, that's because this isn't really meant to be for demonstration purposes. It's just that I really can't stop the video. So I will say that the lowest point on Hank Aaron is a 10. And the highest point, I think we said, was a 47, but I'm going to cheat just a tiny bit, and I'm going to go up to 50, because 47 is very difficult for me to split up, but 10 to 50, I can still split it nicely. So my number line is going to be from 10 to 50, and then I'll put my whisker in not like that. So I need a 20, a 30, and a 40, right? So I'm going to go 20, 30, 40. Something like that. And so my 47 guy, which is my max, is going to be not quite to the 50. And I'm just going to go ahead and draw that whisker there. The maximum is 47. And I'm going to draw this whisker here because we already know he's the minimum. The minimum is 10. Okay? So, go ahead and place all your data points out there and see how it goes. We've got a bunch of them, so I'm going to go 13 here and 27 here. Again, feel free to stop. Oops, I'm going to do 26 there, 27 there. Stop the video, do it yourself, and then pick up and say, yep, I did what she did, or I'm still confused about what she did. 44, 30, 39. I'm trying to label them so that when I come back and try to figure out what the median is or whatever, I can get it pretty quickly. So here's a 34, 45, and there's a second 44. There was a 24, which that was a 25, so 24 down here. 32, somewhere in here. 44, there's a third 44. 39, there's a second 39. 29. 44, there's a fourth 44. 38, right over here somewhere. Second 47 on this whisker up here. A second 34, another 40, there's a 20, a 12, and that 10 that I had, okay? So I'm going to count them up real quickly. I think I have all 23. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. I'm in trouble. Why do I have extras? That's not good. Let me count again. Oh, because I counted stuff that was, no, those were 2, 3, 4, 5, 6. Oh, that wasn't a data point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I've still got 24. I'm just going to go through and check real fast. Sorry. This is why you should put them all in order so that you know where you are. 10, 12, 13, there really is a 20. There was 124, there was not a 25. There was a 26. There was a 27. There was a 29. There was a 30. 32, 34. That's why you put them in order. It's much nicer. 34. It's also much nicer when I have students in the classroom because they can say, oh, you did such and such, and it's just right there and they see it. There's a 38, 2 39s, 2 40s, 1, 2, 3, 4 44s. There's a 45. Oh, there was only 147. That's what it was. It was the maximum, and I had already marked it. That's what it was. So sometimes when there are students in the room, they're like, oh, it's clearly that one right there. And when I'm looking at it, I don't see it. So that's what it is. There's only one data point up here on 47. I'm sorry. Okay. So that's why you label it or put them in order. Put the data points in order if you can, because then it's easier to find any mistakes like that. Okay, so find the median. Well, it should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The 11th guy, 12th guy actually, right? Because it's 23. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now notice that whenever I say 12th data point, okay, it's 34. Unfortunately, whenever I draw my median right through that 34, what just happened? Well, I got my median, but I also picked up an extra data point, right? So unfortunately, that's going to mess with my count. If you look at this now, on the left-hand side, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. But on the right-hand side, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data points. And that was what I was talking about. Sometimes it's just not as nice and pretty as we would like for it to be because it's real-world data. And so things happen. So I picked up an extra data point with my median. That's okay. I'm still going to look at the top half and the bottom half, and I'm going to do as close to 25% as I can. Now think about it. We've got 23 data points. If I divide that by 4, it's almost 24. So that's almost 6 per quarter, right? So it's going to be like 5 3/4 or something like that. So we'll see how that plays out. All right. So, what are we going to do? Let's look at the bottom half. Count up those data points. Figure out what the median of the bottom half would be. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. We actually know we have an 11th guy up here, right? So it should be the 1, 2, 3, 4, 5, 6th guy. Okay. I think it's going to be right in here at the 26. However, if you want to say, and I'm okay with this, and in fact, I'll actually probably change my mind right now. This data point is up here, so I'm going to split between the 5th guy, 1, 2, 3, 4, 5, here at 24, and the 1, 2, 3, 4, 5, 6th guy here at 26, and I'm going to split it right down the middle. That's okay too. Q1, we're going to call it 25, okay? But like I said, if you had said, oh, I'm going to go all the way up to 34 on this one because I know there's a data point up there that got called into the median, it got kind of caught up, then you could call it on the 26, and I'd be perfectly okay with that too. So it really, really is sometimes a little subjective here. Like I said, there are some techniques that you'd find out in an upper stats class, but I'm not stressing out about it right now. So we're just going to do that. What about the top half? We need to find the median of the top half. of the data points. This one actually gets a little bit uglier, or could get a little uglier. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So I'm going to split it right here on the 44. Okay. What that does is it leaves 1, 2, 3, 4, 5 guys in the box. And it leaves this guy here plus 1. And it's got all these sitting here on the Q3, right? Dang it. Because they're all duplicated data points. So again, some people might go, ooh, I really hate that, because when you really count it up, it moves a lot of those data points, or it removes a lot of those data points. And I only have 2 data points here in this top quartile. So some people might say, you know, I'm going to split between 40 and 44. So they might say, I'm going to make my Q3 be 42. Okay. And so I can totally see why they would justify themselves with that. That would give them 5 data points there, and that would give them 6 data points up here. It's still not exactly the same, but at least then I don't just have 2 data points hanging out on that top quartile. So there are little nuances here that we see. Oh, this real world data, and it's because Hank Aaron's got so condensed in his data points. His range is really small, right? He doesn't cover a lot of ground, and he's very consistent, and he's got so many duplicate data points that it makes it more difficult to find an exact point where you're going to split it. Okay, so here I split it between the 2. Here I did not. Okay, and if you want to, you could just as easily say this is a 42 and split it right there, and I would be okay with it. So I'm not really going to stress out about that either direction, which way you go, as long as you can show me your work and why you did it. So what you can see here is that making a box and whiskers plot is really about plotting data points, counting data points, and being able to take an average. That's really what's involved. It's not really terribly difficult math. It's just a matter of paying attention to what's going on here, right? All right. Now, when I look at this box, I see it's kind of shifted towards the up side of things. This whisker is really stretched out. This whisker is really short. Okay. And whenever I think about that, again, we got to say, oh, we've got about 25% of our data, right? And this needs to be about 25% of our data, or as close as I can get it. So when I think about that, why is it stretched out down here, but it's really close together? And that bugs people, because a lot of times, I started to say this earlier, a lot of times people will say, no, 25% is exactly 1/4. And so when you're doing this, make sure that you are finding, when you look at 25%, it's of the data points. Okay, of the data points, no matter how spread out they are. Okay. So it doesn't matter if they're really close together or if they're really far apart. This 25% that's kind of spread out, it's because he didn't have a lot of teens, right? 10, 12, 13. Those were his only teens. And then he started way up here at 20, 24, and so on. But that's about the same number of data points, 1, 2, 3, 4, 5, as I have up here, 1, 2, 3, 4, 5. So it's the number of data points that I'm looking at. It is not the distance. So we're not splitting the distance equally into 4s, and that bugs people, right? When I set up my number line, I tried to make the number line as evenly spaced as I could. But look here, we said that this was Babe Ruth, this was 25%, and this was 25%. That bugs people, students sometimes, because they equate 25% to mean 1/4 of the distance here. Well, 1/4 of the distance would have been like split there and split here, right? But we're not talking 1/4 of the distance. Be careful, careful, careful. We're talking about 1/4 of the data points. So it's 5 data points here, 5 data points here, 5 here, 5 here. approximately. So, and these are just, they happen to be 5 data points because we had 22 seasons and 23 seasons. If I had 40 data points, then I'd have about 10 data points here, 10 data points here, 10 data points here, and 10 data points here. So don't get bogged down with, oh, this needs to be evenly spaced, because it will not be evenly spaced. So these quartiles are not evenly spaced. They are not the same distance. And the area in the bottom half of the box does not have to be equal to the area in the top half of the box. And I think if you'll get that out of your head, like, don't get stuck on that. Okay, let me show you one more time. The quartiles are not evenly spaced. They are not the same distance, and the area on the bottom half of the box does not have to be equal to the area of the top half of the box. So here the boxes are close to the same space, right? But in the one for Babe Ruth, clearly the area here in the bottom half of his box is a lot bigger than the area in the top half of his box, right? This whisker at the top is more spread out than this whisker at the bottom. So it's not about distance, it's not about area. So it's not a fraction. Don't think it's a fraction of this distance or something like that. That's not what we're talking about. We're talking about 25% of the data points. Okay, so I don't know how else I can stress that, but count the data points and figure out what 25% of it is. Okay, so think, how big is 1/4 of the data points? That's what we should be thinking. Okay, and in this case, 22 divided by 4 is approximately 5.5, I think, right? So, I think it is. So, anyway, I don't want to do that math. Yeah, 5.5, that's it. Too late, I did the math in my head. Okay, so that's the idea behind making a box and whiskers plot. And again, hold on to these particular box and whiskers plots. Hopefully you're making notes and copying this down on your own paper, and you can refer back to it, because whenever we come back and we do a little bit more of the statistics work with these, I'm going to be going through and talking about what happens with that. Okay, so we'll use these exact same box and whiskers. All right, that's it for that. Have a great day.